To be continued. In general, in a number of critical areas of technology, plain bearings have predominant application. They are versatile and provide reliable, durable operation of the support units of extra heavy shafts. High accuracy of precision machines. The plain bearings operate reliably at high shaft speeds. And in adverse temperature conditions, as well as in a polluted and aggressive environment. They are insensitive to high shock and vibration loads. The performance of plain bearings is due to the simplicity of their design. Thus, the most common radial plain bearing in technology consists of a steel or cast iron housing and an insert made of anti-friction materials. Bronzes, brass, anti-friction, cast iron, aluminum alloys, and various plastics. The distal liners have an anti-friction coating made of bobbin. The liner has oil supply holes and lubrication grooves. The sliding bearings are usually detachable, which simplifies the installation of the supporting units of the machines. Friction co-surfaces in the plain bearing are separated by a layer of grease. The thickness of the grease layer should be sufficient to prevent contact between the friction co-surfaces, which lead to their wear and large losses to overcome friction. In bearings, it is necessary to provide a mode of pure liquid friction, in which there is no contact between the rubbing co-surfaces and friction occurs only between the layers separating their lubricants. The ability of the plain bearings to withstand heavy loads while maintaining fluid friction is due to the presence of a wedge gap between the friction surfaces filled with lubricant. Consider the conditions for the formation of an oil plate on the example of an unlimited plane covered with a layer of lubricant and located to it at a certain angle of the plate. With their relative movement, the viscous lubricant, due to internal friction, is carried away into a wedge-shaped gap. The wedge-shaped gap creates resistance to the movement of the viscous lubricant, and, in accordance with the law of continuity of the flow of practically non-compressible liquid, excess pressure arises in the formed oil wedge. At a certain relative speed, the excess pressure in the oil wedge is able to balance the external load and provide a liquid friction mode. The greater the relative velocity of the friction surfaces, the greater the magnitude of the overpressure and the bearing capacity of the oil wedge. At high relative speeds, water and kerosene are used instead of oil. Gas lubricant is used at high speeds of up to 300,000 revolutions per minute. Sliding bearings that use the effect of an oil wedge are called hydrodynamic. Radial plain bearings are the most widely used in technology. In them, an oil wedge is created due to the eccentric arrangement of the trunnion in the liner. The resulting oil wedge, due to the increased pressure in it, has a bearing capacity and squeezes the loaded rotating oil. It has a bearing capacity and squeezes the loaded rotating trunnion upwards and somewhat in the direction of its rotation. The movement of the center of the trunnion continues until the resultant forces of pressure and the forces of internal drift balance the external load. Therefore, the trajectory of the center of the trunnion is called the moving equilibrium curve. At high speeds and minor loads, the center of the trunnion can theoretically coincide with the center of the bearing. In such bearings, undamped oscillations of the shaft can occur with a frequency approximately equal to half of the angular speed of its rotation. Vibration can lead to rupture of the oil layer, which causes intense wear of rubbing surfaces and inconvenience. And bearing failure. To reduce the possibility of vibrations in the bearings of high-speed machines, the area of the working area of the liner is reduced to increase the specific load. High anti-vibration properties are possessed by sliding bearings with maple sprouts of liners, where the trunnion rests on several oil wedges, which reduces the possibility of its vibrations. To be continued. Hydrodynamic plane bearings have an important property: to damp the impact loads on the shaft, which increases the reliability and durability of the machines. The basics of hydrodynamic theory were developed by outstanding scientists Petrov, Reynolds, Zhukovsky, Chaplygin. With apparent resistance, the physical phenomena occurring in the sliding bearings operating in the liquid friction mode are extremely complex, the study of which continues. Dynamic music.